your mind is that this is a chemistry course. So what do chemists do? What do they study? What is chemistry about? What we talk about in chemistry? Yes? Studying matter. What exactly are we studying about matter? Yes? Properties. Okay, other than that, other than the properties,
the way that it interacts with the world around it.
The way that it reacts with the surrounding or things around it. And that's exactly what we do in chemistry. So in chemistry, we study the change, the chemical change or transformation of matter. So chemistry is unlike physical process. A chemical process is a change, a transformation of the matter. An example of a physical process is melting ice. So a physical process, an example of that is melting ice. So let's say I have in a cup some ice. If I heat it or I just keep it at room temperature, it's going to go to water. It's going to change to water. If I heat it a little bit more, it's going to go into vapor. So at the beginning, I started with water, but in the solid form. It's in here water, but in the liquid form. And in the vapor form, it is water, but it's in the gas phase. In other words, a physical process, the thing is still the same all during the process. In a chemical change, as the one that Jake gonna show us in a minute, so he can get us started. So we have, for example, hydrogen peroxide. A 10% hydrogen peroxide is what we use in the first aid. Usually it decomposes to water plus oxygen. And maybe add a little bit more detection. Okay, as you can see, this is a kind of chemical reaction. Okay, so a chemical reaction, first of all, as you can see, it's giving heat. And as you can see, the thing is transformed. And the reason that it's kind of bubbled, it's bubbled really. It's bubbled there because you have oxygen and the oxygen is bubbling and going up. So the difference between a physical process and a chemical process is mainly that we're changing the matter. We change it from hydrogen peroxide to water and oxygen. While in the physical process, we just went from water solid to water liquid to a vapor. So, as we said, the study of the chemical change or transformation in chemistry, we study the change and transformation of matter. So, what is matter? So, matter is mainly anything that has a mass and occupies a volume. The air in this room that we just breathing right now is a matter. Why? Because it has a tiny mass, yet it is occupying the volume of this class or of this room. So a matter can be invisible. Gases are matter, but it can be invisible or visible. My cell phone is a matter. The table in here is a matter. Okay? So air is a matter, but it cannot be seen. So matter is anything around us that has a mass and occupies a space. Now, each matter can go into three states. Most of them. There is one or two exceptions which we're not going to talk about in this class. So the matter can be either solid. This is one state of the matter. It can be liquid. It can go to gas. An example of that is water that I just talked about. It can be in the solid state if it is at temperature around 0 or lower. It If I heat it a little bit, I can go to the liquid. If I heat it a little bit more, it can go to the vapor state. Now, sometimes we say, okay, iron is solid. That means that iron is solid under the condition of this earth, that means the 1 atmospheric pressure, and at room temperature. So if I heat the iron more, it can go to the liquid. If I heat it much, much, much more, it can go to the vapor state. So what we refer to as a solid liquid, so later on in chapter 2, I'll refer to the periodic table and say, for example, copper is solid. What I mean that is copper is solid at the condition of this earth, which is room temperature and the atmospheric pressure that we are at. So any matter can go through these three phases, solid, liquid, and gas. It just depends on the conditions. So from now on, when I say something is liquid, I mean at the temperature of this room or the temperature of our earth and at 1 atmosphere. Now, usually the particles of the solid, they are closer to each other and they are compact, more close to each other. Now, for the liquid, they are a little bit far apart, but not too much. For the gas, they are far, far away from each other. Okay? Now, to go from the solid to the liquid, we usually heat the material. We kind of heat the ice to go from ice to water. And when we heat, we give those particles kinetic energy. And they begin vibrating in their place and go a little bit apart from each other. Then if I heat much more, those gas particles are far, far away from each other. So in the solid, it have a definitive shape as the iron. For example, if I have a block of iron, it has a definitive shape. The liquid, it takes the shape of the container that it is in. And the gas is just everywhere where you are in where it is. Okay? So we call this, when we go from the solid to the liquid to gas, that we heat, we increase the temperature, that we go from solid to liquid to gas, the kinetic molecular theory, which is a fancy name to say changing by heat. By giving the sample a heat, the particles begin moving in their place and then get a little bit apart. That's a liquid. More apart, that's a gas. Okay? I think most of you heard that in high school. I'm just repeating it just in case you didn't hear about it before. Now, in chemistry, we usually talk about stuff in two ways. In a qualitative, or we describe the property of any chemical in two ways. Qualitative and quantitative. The qualitative, no numbers. I would never say any number. I would say it's blue in color, it's purple in color, it's liquid, it's gas, no numbers. I would give no numbers. In the quantitative, I'm going to give numbers like density. The density of this material is 2 point something. The weight, the temperature, the length, anything that has a number is a quantitative description of the material or of the chemical. And you need to know that we usually do these properties. If you go to any chemical company, you open the chemical properties of any compound, you're going to see some qualitative and some quantitative. And you should be able to know the difference. What is a qualitative and what is a quantitative? So those are some physical properties of the material. The color is a physical property. The state of matter, whether it is liquid, gas, or solid at room temperature, is also a physical property. The melting point that we usually refer to as MP. The boiling point, we usually refer to as TP. The density. Now, the solubility, whether it is soluble in water or not, this is what we're going to discuss in chapter 4. We're going to discuss it in chapter 1 on Monday. Now, the other 3 properties we'll rarely hear about, at least in this basic chemistry course. So all of these are, till now, when we're talking about the color, the density, the length, yes, part of it is quantitative, the other part is qualitative, yet we didn't talk about the chemical properties. We're just describing physical properties, nothing about the chemical yet. Okay, let's do an eye clicker. the first 2 weeks is going to be an easy, very easy eye clicker, just for the sake of the practice, and it's going to go a little bit harder as we go. So, during the eye clicker, you can talk to each other, to anybody around you. I'm going to stop that at 2 minutes. So this is telling you the time. I'm going to stop it at 2. So the way that you're going to vote is the following. First, you turn on your eye clicker. You hit the refresh button. Then you're going to press 1, 2, 3. Now the 1, 2, you have ABC down there. You have on the eye clicker ABC. I have no eye clicker. Can somebody just thank you? So we have the ABCD. This is not how we're going to vote. We're going to vote 1, 2, or 3. So if you vote 1, you think B and C are qualitative properties. And the way that you're going to do it is use the arrow up. So the number that you see is 1. If you want to vote for 2, you press 1 more, it's going to show you 2. If you want a 3, you press 1 more, it's a 3. Then after that, even if you do 3, it's not yet on my system until you hit send. When you hit send, you're going to see a check mark saying yes, you did send it. If you don't see that check mark, that implies that you didn't put to the same frequency. Okay, thank you so much. So, which of the following observation is qualitative? You can talk to each other. You still have some time. I'm going to stop it at 2 minutes. Okay, so I'm gonna shut down the eye clicker. It's okay if it didn't work for the moment. It's not gonna be graded. Most of the time, if you still don't know, just ask the person next to you. They know it from another class or they figured it out already. So I'm gonna stop that and check what. So most of the class, about 94% of the class, answered 2. And the right answer. So first, a piece of metal is blue in color. That's right, that's a qualitative. The density of a metal block is 2.65, that's a quantitative. And the mass of the block is also quantitative. So the right answer is number 2. And by the way, this is how I do multiple choice in the exams. It's kind of like this. Could be a little bit higher level because this is a very simple question, but this is what you should get used to. Something like multiple choice in the exam. Now, we're gonna begin classifying the classification of matter. So the matter in this universe, in this earth, on this earth, it can be either a mixture or a pure matter. It's either a mixture or pure. The mixture can be either homogeneous or heterogeneous. Now the pure matter can be either a component or an element. Now, to go from a mixture to a pure matter, we do physical process. We're going to talk in detail what do I mean by separating via physical process. Now, to go from a compound to an element and from an element to a compound, that's a chemical reaction or a chemical process. And Rx and I refer to it as reaction. So this is the classification of matter. Today we're going to talk about this classification, the difference between those, and what does every one of these mean. I already have a slide for you, writing it in a better way. If my handwriting is not, you can't read it, although I don't think so. So this is kind of another slide that show you all what I've brought there. So this is the matter. So what we're going to begin with is mixtures. An example of that, like water and salt, this mixture of beans, oil and water. Here we have sand and water. So all of these are mixture. Another example is this iron, small pieces, and sugar. They are together. And Jake today gonna show us the separation, not right now, in a bit. This is copper sulfate in water, and this is just copper sulfate alone. So mainly we have those four mixtures in there. Now we said that there are two kinds of mixture, heterogeneous and homogeneous. And I think just from saying it, homogeneous means that it is kind of one phase. You see only one phase. Heterogeneous, you see two phases. You can separate by your eye that there are two phases. For example, let's say water and salt. How many phases do you see? One. So this is a homogeneous mixture. That's a homogeneous mixture because you see only one phase. While maybe if we can get, so this is sugar plus iron, small pieces. If you look at it, it looks like two phases. You can see some white kind of pieces and some other black pieces in there. And just to prove to you that this is two stuff, if I take the magnet, I'm not sure if everybody can see it in the back, so Jake's gonna take it to the, walk slowly up there so that you can see it. So it's a heterogeneous mixture. Why? Because you can see two phases. These beans in here is a mixture and it is heterogeneous. This is homogeneous. Now the oil and water, is that a hetero or homo mixture? How many phases do you see? Two. So what does that tell you? Vague. What about this? You have sand and water. How many phases do you see? What does that imply? Hetero. Very good. So this is the rule of thumb. If you see two phases, directly that's a heterogeneous mixture. If you see one phase that you don't see but that's a homogeneous. What if you see three? Still hetero. What if you see four? Still hetero. 10. It doesn't matter. It's heterogeneous. So this is the definition of the mixture. This is the classification of homogeneous and heterogeneous. Now we're gonna just do kind of the definition. So matter containing two or more substances that are present in variable amounts, that's the definition of a mixture. And I just wanna comment on the idea of variable amounts. So in the example of the oil and water, I can either add more oil or add more water. That wouldn't change it from heterogeneous to homogeneous mixture, right? The same for salt and water. I can add 1 gram of salt to that cup of water, or I can add 2 grams of salt to that cup of water. At the end of the day, you're looking at it and it is one phase and it's homogeneous. And this is what it means by present in variable amount. It doesn't matter how much you add, as long when you look at it, if it is one phase, it is homogeneous. If it is two phases or more, it's heterogeneous. So mixture are variable in composition. You can vary it, it's still a mixture. They can be, as we said, either homogeneous or heterogeneous. We already talked about the homogeneous mixture as being composed of two or more substances that has one phase, sugar in water, salt in water, anything that dissolves in water. An example of that is copper sulfate. You see one phase. There is no two phases. You see colored thing, and it is one phase. That's a homogeneous mixture. Now, a heterogeneous mixture is a mixture consists of two or more phases. Can be two solids like sugar and sand, iron filings, and sand. Can be liquid and solid like the soup that we eat. It is a heterogeneous mixture. There is two exceptions for this kind of rule: is the blood and the milk. So if you take the milk, you look at it, you see one phase. Yet if you put it in the path of a light, you're gonna see particles in there that are just suspended inside the milk. This is why milk and the blood, although they look for the first moment as one phase, they are considered heterogeneous mixtures. This is how we define it, because when we put it in a path, in the light path, we're gonna see the particles suspended, not totally dissolved in the mixture. So these are the only two exceptions that you're gonna hear about. That if you look at it, it's not obvious that it is heterogeneous mixture. Okay. Now we said if you go back to that map that I did. So we said we have hetero and homogeneous mixture. Usually we go from this one, we can go from heterogeneous mixture to the pure matter. So from here to the pure matter by physical processes. One of them is what Jacob just did for the iron pieces. He used magnet to separate them, and that using the magnet to separate the two, that implies you did a physical process. The iron is still iron, the sugar is still sugar, no change in the chemistry of both of these. You just separate them from each other, and this is the physical process. Okay? Even salt and water, if this is the salt and water, the way to separate them is sometimes it's just by evaporating the water and collecting it, and we'll end up with the salt in here. This is also a physical process. We call this process distillation process. So anytime we want to go from a heterogeneous or homogeneous mixture to pure matter, we do a physical process, not a chemical process. To go from a heterogeneous or homogeneous to pure matter, it's always a physical process. Now, when we do any physical separation, yes?
I'm sorry, can you just explain that again? Which one is it physical and which one is chemical? To go back and forth?
So the chemical one we didn't talk about yet is to go from element. Sorry. If we want to go from element to compound, that's a chemical process. The others are physical processes. Now, a physical separation, when we do physical separation, we're depending on the physical properties of the matter, not the chemical one. An example of that is density. In the example that we just showed about oil and water, they are separated. The oil is in the top of the water because it has a lower density. So we use the density to have these two phases, and simply if I have water and oil, I can simply open the bottle, pour the oil until I get rid of all the oil in a beaker, then I'll have separate them. So I use the density, the difference in the density between the two, kind of to separate them. This is one kind of separation, and the fancy name for just pouring the oil and keeping the water is decantation. This is just a very fancy chemical, like the chemists use this technical word, decantation, and all what it means, if you have two liquid phases, you take the upper layer, pour it, and keep the lower layer. Now, boiling point, let's say I have two liquids together, water and ethanol. I know, for example, that water boils at 100, that ethanol boils at 78, so I do distillation. So if I can separate, if the boiling point of the two liquids is far apart, I can separate them by distillation. State of matter. So if one of them is solid, the other one is liquid, an example of that is having sand and water. One is solid, one is liquid. It's a heterogeneous mixture. If I want to separate them, I simply do filtration. Now the others we usually don't use in this course. Magnetism definitely if we have, but the other stuff we're not gonna talk about in this class. So we can use the density, the boiling point, and the state of matter. And we mean by the state of matter whether it is gas, liquid, solid. If one is liquid, the other is solid, we can do filtration, and this is so. These are the way the physical separation. We want to go from heterogeneous and homogeneous mixtures to pure matter. Now what we're going to talk about is pure substances, which is the other part of matter. So what is a pure substance? A pure substance is something that have unique properties. It have unique melting point, a unique boiling point. It cannot be separated into two or more different species by physical process. Okay, that definition is kind of a gray area. What does that mean? First, an example of that is water. Everybody in this class, I think they know that water evaporates at 100 degrees centigrade and it freezes at 0 degrees centigrade. So water is a pure matter because wherever you go in this universe, the boiling point and the melting point is the same. Now water, if I take water, do filtration, if I put a magnet next to the water, if any of the physical process that we did, at the end of the day, I'm gonna end up with water. Even if I heat it up, I'm gonna change it from water to water vapor. So at the end of the day, I can't change it by physical process to something else. It's gonna stay water. So this is the definition of a pure substance. An example of pure substance is water, metal. This is the definition of pure. Now, as we said that pure matter, according to this chart, it can be either a compound or an element. And we're gonna kind of learn what is a compound and what is an element. Now, elements. Look to that periodic table up there. Anything from that periodic table is considered an element. And Jay's gonna show you some metals out there which are elements. So anything as it is from the periodic table, it is an element. So copper, if I tell you copper, it is an element. If I say chromium, it is an element. Potassium, it is an element. Now, the exception for that is hydrogen. Hydrogen does not exist by itself. You can't see a hydrogen just alone in this universe. It's going to be H2. It exists in a diatomic form. So H2 is an element. O2, also oxygen, does not exist as it is. So O2, oxygen, is an element. Okay? So those atoms that they don't exist alone, they are elements in their diatomic form. Okay? Like fluorine. All group 7A, fluorine, chlorine, bromine, iodine, they don't exist as they are, they exist in their diatomic form, and the diatomic form is considered an element. The others, they can exist by themselves, like silicon by itself, so that's an element. So Jake is showing you some lead, that's an element. Lead is Pb and it is copper, it is an element. Take this, copper and what do we have? Carbon, carbon, it is an element. Carbon, it is an element. So anything from the periodic table as it is an element with the exception of hydrogen, H2, O2, with an exception of Cl2, F2, Al2. They exist in the diatomic form, and all of these are considered elements. Okay? Makes sense? Yeah. That's right. And 2 is the diatomic. That's right. So any element that does not exist as it is, like cannot be just nitrogen out there. It is also an element. Now, what is a compound? And by definition, an element, let's say if I have a copper and I keep breaking it into small pieces and small pieces and small pieces, it's not going to go to anything else. I'm not talking about the subatomic particles or protons and neutrons at this level or the electrons. I'm talking about the material itself. If I'm breaking it into small pieces and small pieces and small pieces, it's going to stay as it is copper. So the element is the smallest thing out there. Okay? Now, as I said, you have 117 elements out there in the periodic table. All of these are elements. Now we're gonna talk about compounds. So a compound is the combination of two elements, two different elements, like hydrogen and Cl, HCl. It is a compound. Let's say NaCl. It is a compound. So a compound is the combination of two different elements connected by a chemical bond. It can be ionic or covalent. An example of that is water. H2O is a pure substance that is a compound. Okay? NaCl, which is the tablet salt that we use at home, is also a compound. The sand, it is made of silicon oxide, and it is a compound. Sugar, it is carbon, hydrogen, and oxygen with different amount, X and Y and Z, and that's also a compound. So how are you going to differentiate between an element and a compound? An element is simply you're going to see one like H2, sodium, Na, calcium, Ca. While a compound, you're going to see two elements together in the same molecular formula. And the numbers, how many hydrogen do you have in there and how many oxygen do you have in there is not variable. For example, water. Whenever I say water, it's definitely H2O. It couldn't be, for example, HO. It couldn't, if we're talking about water, this is what it is. It's H2O. OH is another thing. It's hydroxide. If it is H2O2, it's hydrogen peroxide. So in other words, a compound is a combination of two elements and they have a specific molecular formula, a specific formula. And it's not only having hydrogen and oxygen. Let's say I have in a closed beaker or flask H2 and O2. H2 gas and O2 gas. Is that considered a compound? No. because H2 is alone and O2 is alone. They don't have a chemical bonding between them, but they are in the same flask. This is a gas mixture. For that to be considered a compound, the hydrogen and the oxygen should have bond together. That's the example of water. You have the oxygen have a chemical bond with the hydrogen, the oxygen have a chemical bond with the hydrogen. Make sense? Any question? Yeah. Something like ozone. Okay, that's, yeah, it's okay. Ozone is considered, and we say it's ozone. I'm not sure if we consider that element or compound, but my guess it's element. So, an example. So how we prepare those compounds? An example of them is NaCl, which is the tablet salt that we use at home. It is usually made from sodium solid, which is an element, and Cl2 gas. Usually sodium is a material that is so sensitive to water. If you put it in water, we're gonna see that later on during this course. We're gonna add sodium to water and it's kind of explosive because it forms H2 and it is explosive. Cl2 is poisonous. If we just smell Cl2, it's poisonous. So we form NaCl by the addition of Na solid plus Cl2 gas to form NaCl. So this is a compound, right? And Na, as we agreed, it's an element. And Cl2 is an element. So as you can see that combining two elements can give us a compound. Combining an element plus a compound can give us a compound. So to go from a compound to an element, from an element to a compound, it's chemical reaction. It's not a physical process. Okay? So to go from an element to a compound, it's a chemical process, not a physical process. Because when sodium reacted with Cl2, it wasn't a physical process. It was a chemical process. And that brings us back to the chart where we said to go from heterogeneous and homogeneous to pure stuff, we do physical separation to go from an element to a compound, and from compound to an element, it is a chemical process. Now, we can make copper sulfate from copper plus H2SO4. Now, the difference between this is an element and copper sulfate is a compound. This is copper, and this is copper sulfate. The color is different. In here it's solid, in here it's solid, but it's kind of more a crystal if you take a closer look, it's kind of a crystal. So that tells you that in a chemical process, this is a chemical process, not a physical process. When we go from copper to copper sulfate, is a total change of the property of the material. Copper in its element form is solid with a copper color here, and copper sulfate, it is blue. So in any chemical process, we're changing the properties of the material. We're changing everything about it. So in any chemical change, the compound and its element, they have different properties. So you can't guess, oh, if copper is copper in color, so copper sulfate should be copper in. They should have a copper color. It doesn't match. The properties, once you do a chemical reaction, the qualitative and quantitative properties are different after that. So, a physical, let's just summarize what is a physical process. It's the density is a physical property or process. Color, melting point and boiling point. Evaporation is another process that we use to separate compounds like water and salt. We evaporate, we get rid of the water, we just keep the solid. Dissolving substance is also a physical process. Condensation is a physical process. Who knows what is condensation? Yeah. Very good. So it is a change of state from vapor. It's just if you have a gas, you want it to change it from gas to liquid. This is condensation. So all of these are physical process. A chemical process, a chemical property or a chemical process is reaction. Combustion reaction is a chemical process like burning an egg. Reaction with other compounds like HCl, Na, solid plus HCl. All of these is a chemical reaction. And we're going to talk about chemical reaction. So from here is just a very basic. Most of you, I think they know that from high school. This is a very basic, the classification of matter from mixtures, pure substance, what is element and compounds being under pure substance, and mixture, how to separate them. And from now on, we're going to begin talking about chemical reaction. Okay. An example of a chemical reaction is the combustion of methane, which is the methane. If I use this Bunsen burner, turning it on and burning it, that's a burning of methane. And we call this reaction combustion. So a combustion reaction is the reaction of any chemical, whether it is metal or organic material like methane, plus oxygen. And in the case of organic matter, when you do combustion, you're going to have CO2 plus water. So burning methane or burning wood or burning anything out there, it is a chemical reaction. You're going from methane, which is a gas, and oxygen, which is in the air, to give CO2 gas and H2O gas. And H2O has, the properties of H2O has nothing to do with methane or with oxygen. So this is a chemical reaction. And definitely this is not balanced, yes. Whatever I wrote there is not a balanced equation. So a chemical reaction in here, is this a compound or an element? Compound. Okay. Is this a compound or element? Thank you. Is this a compound or an element? Compound or element? So as you can see, compounds can react with elements to give two compounds or any other combination. Now, so the thing that we're going to talk about on, this is what we're going to handle from now on. We're really going to talk about the physical processes. We're only going to talk about it in chapter 5, about the physical processes, but most of this course is about reactions. On Monday, we're going to do a little bit of a review on how to deal with conversions, to convert it from one unit to the other. I would ask all of you to do kind of a review, how to do conversions from one unit to the other, to kind of do a review for the basic, very basic math, basic algebra before coming in here Monday. Remember that your first assignment is due Monday at 11:59 p.m. Have a nice weekend and I'll see you